Please welcome Dr. Matthias Burger and one of the brightest spark in his team, Felix Meyer zu Driehausen from Bosch.
That one works. So yeah, thank you very much. Today, Felix and me, we just want to talk about create flow in software engineering. Just sharing some thoughts in the context of cross-domain computing solutions. So, cross-domain computing solutions. This is a business unit at Robert Bosch, which comprises assisted and automated driving, software and services, EE architectures, cockpit solutions. Today we will focus only on assisted and automated driving, but of course what we will tell is also relevant for all the other products. So what do we talk about? There are a lot of functions available for assisted and automated driving, starting with safety. Safety is our business, emergency braking, emergency steering, saving lives. I think this is an essential goal, but of course also comfort. So adaptive cruise control, lane assist, I think we all know that and like it. And of course there are a lot of other features also available, like level 2 functions, helping overtaking cars, and not to forget the pilots, which will come up in future, highway pilot, traffic jam pilot, level 3 functions. So if we talk about driving, we should not forget parking. There are also a lot of functions available, and the grade of automation is even higher at parking than at driving. So park steering control, remote park assist, home park assist are automated features, and safety is also a very important case at parking. So for example, emergency braking, misstart prevention, and also reverse pedestrian protection. Do not want to go in details with 3D visualization. This of course is also a feature which we supply. What I want to show is there are a lot of functions available. And this perfectly fits to that what Miro showed before, all that configurations we do have. This is enormous complexity which we have, because every customer wants a tailored solution, or say it in other words, Miro showed it, needs a tailored solution. So there are very specific requirements by our customers, and what we have to meet are a flexible configuration. And this is a further point of complexity which we have to cope with. So if we look at the entire stack, starting with the sensor set, which varies, then the compute hardware, central compute hardware, SoCs, the operation system, base software, middleware, we saw different solutions there where we also have to cope with, and then the application software where the functions are on. And not to forget, which will also be relevant in futures, are services, cloud-based services, wrong driver warning detection, friction maps, and so on and so on. So the question is, how can we handle all that variations in our business? Because one thing is clear, and I think this is very essential, different to other software businesses, that we cannot bring down the variations. Variation is our business, and because of that, we somehow have to find a way how to handle it. And then there is another point of complexity which comes up in future with software-defined vehicles. And our chairman, Markus Hein, I think stated that very clearly. In future, the customer wants to have a seamless integration. So it is like, we heard that a few times today, like a smartphone. So hardware stays constant, but the product on itself changes permanently, gets better, you get a better feeling. And this is also requested in vehicles. So we need constant updates, we need new features, not only from comfort perspective, but also from safety and security that will be demanded, that updates have to be done over lifetime. So we need a sort of maintenance. So one thing is really belongs to the past, that we can make a customer-specific solution, bring it to a control unit, file it, and forget it. That will be past. So we will have to maintain the software over lifetime. So speed of development is a point, and we have to update that within days, not within weeks, bringing to the vehicles. And of course, we also heard decoupling of software and hardware is very essential to make that possible, that we have software updates and upgrades permanently. So the basic question is, how can we handle all that complexity? And here is one solution which we want to show you. So this is how we do it at our business unit. So we have a configurable software platform solution. On the left side, there are application software components which can be reused. And then we have some integration platforms. Not very much, but for example, driving and parking is an integration platform where we bring together or integrate the software components and bring it up to a viable product. And on that, customer-specific solutions are then done. So now, if we do have an update on software components on the left side, then we integrate it to the platform and then we bring it to the customer-specific solutions. So this is a very efficient supply chain, but it is also a very sensitive delivery pipeline. So, for example, if we are too slow, then customer-specific solutions are demanded, but cannot be delivered from the left side, and then we will get special solutions. We will get patches, clones. And then we will have a decoupling of this integration pipeline. So code divergence. So we are incompatible. So we cannot integrate from left to right in an easy way. It gets more and more complex. We get slower and slower and slower. So this is a vicious circle. And that will end up in a collapse, so that the entire chain breaks. And we have a lot of customer-specific solutions which have to be maintained. Nobody can pay that. Because of that, we have to take care of this chain. We have to control it. And this is, I think, the essential message today. We have to create flow, like we did that in past, in hardware manufacturing, so that we continuously improve the productivity with real-time KPIs, and in that way create flow and control the entire supply chain. And some essential examples, just to make it very clear, where are the points we have to take care, will now show Felix.
Thank you, Matthias. Create flow. As Matthias mentioned, we draw the parallels here from production, and we bring also some kind of wording into the software world here. Matthias showed this delivery chain with the applications on the left side. Here again on the left side, this is actually where we invest. And this is where we want the highest possible reuse. So these are the components that go into the integration platforms, that go into all the customer-specific solutions in the end. So we want to invest in those because the reuse is high. If we implement new features, this will have an effect on a lot of customer-specific solutions where we, as a tier one, can generate our value. So the invest is on the horizontals here, continuous development of our components, capturing the value happens in the verticals, integrated and customer-specific solutions. Here I brought 3 layers, three examples that are bound together into this vertical. For example, application software like driving, ACC, AEB, application software like parking with the examples that Matthias mentioned. And as well, we have spoken about it quite a bit today, the middleware. So what are we doing now to improve the flow along these delivery chains? First of all, we make the flow visible. And we introduce some metrics here. Some of those are really familiar probably with many of you. DORA metrics, accelerate KPIs in other words. So lead time, deployment frequency, mean time to repair, change failure rate. These are things that we have mapped onto our delivery chain so that at each handover point we can have an indicator here. Why is this important? If you are investing in the continuous development of the components and the component development is only getting a very delayed feedback from the customer-specific solutions, there's a high chance that the investment that you take are not targeted enough. So with these metrics, we can basically measure how long it takes for developers to get a feedback from a customer-specific solution, so they know that not only in their reference in the component the change is beneficial, but also across a large variety of customer-specific solutions. In addition to that matrix, we have introduced something else which we call integration lag. And this integration lag really now nails it down. Yeah? It really captures how much development has been ongoing in a component that is not yet integrated, not yet used in the customer-specific solutions. And there's a technical definition here as well. It's really going down into the source control management systems, really checking, okay, are there commits? How old are these commits if they have not been integrated in the customer-specific solution, and make that very transparent. We have developed, to do this and to do this at scale, we have developed a Bosch monitoring and analytics service. Not go into all the details. Important takeaway there is, across our distributed development landscape, of course there are many different tools, many different GitHub, Bitbucket, all kind of version control systems, package managers like Conan, ticket systems of different kinds. All of those tools we have, we're happy to use them, they're modern tools, but for this measurement, of course, we have to support each and every one of them to get all the data together to really monitor these metrics that we have. Our Bosch monitoring and analytics service provides us with this. I will bring this short exemplary case study to really show why this is so absolutely important, that we have a clear view on how the flow is in our distributed software engineering. So here again, in the top, we see exemplary, could be something else, a driving application software. In the bottom, we have the parking application software, and then we have the middleware again. So and we see, because we want to make also use of different middleware, sometimes we cannot decide which middleware is used. There's an integration platform which you see in the middle for the driving as well as also for the parking. So it's the first time that the business logic from the driving or the business logic from the parking is depending then on the middleware and is communicating via the specific middleware. Of course, that's why there are the errors which indicate a dependency here from the middleware to the driving and to the parking. But then on the right-hand side, of course, driving and parking, some centralized architectures come together on a SoC, and everything has to be bound together depending on the same middleware. That's what you can see on the right. And here also we spoke about co-creation scenarios. It could be that this is not in the hand of a tier one, it could be that this happens at the OEM, etc., in other co-creation scenarios. So that's why it's important to have at every one of those dependencies the measurement points for the specific metrics that we have introduced to really get the full picture and to be able to steer and see in case there are any bottlenecks at any point. Here's some exemplary numbers, yeah, not just exemplary case study for this integration lag. So we can see that some handover points works quite well, very quick handover. At some points, it takes a little bit longer. Also, we can see that the middleware here, and this is a point I want to highlight, there are 20 days towards the driving stream integration lag, 20 days into the complete stack on the right-hand side, and the parking, only 7 days. So parking has a newer version of the middleware, which good thing. Yeah. But then in the end, we see now we have a kind of a diamond dependency structure. The middleware is dependent on by the driving, by the parking as well. In the end, everything comes together on the right-hand side again. Well, what does it mean? Yeah. Now, parking has updated the middleware already. Yeah. When maybe this new version of the middleware is not compatible with the old version anymore. Yeah. Hopefully this doesn't occur, but in case it occurs, it really means that the parking updates towards the right-hand side cannot be delivered anymore because there's an incompatibility with respect to the middleware. So really, what we can see here is that in this, with the update, you're dependent on the slowest in the entire picture. And that's a challenge. And that's the reason why we have to have this transparency, and we have to be actively steering these delivery chains, as we have multiple players in co-creations, multiple big divisions within a company working together to provide software for centralized architectures. Okay, if now something seems to be a bottleneck and isn't running as expected, maybe you see, okay, there's a large integration lag, so there's been a lot of development which has not been taken on in the customer solutions. We have to inspect and adapt. And this is where we believe it needs to be possible to do a Gemba walk, go to where it happens, also in software development, in a software factory. And not everybody is regularly in the code, besides that the code base, as we heard, sometimes are so huge that it's not even possible to have an overview over everything. So this is where we have been using Seerene for a specific case as well. So coming back to the picture with the component, there's a development ongoing in the component. This is where the invest takes place. So you can see here in the bottom map of Seerene, this is the rate of change per file over a specific period of time on one of our platform developments. And the development is ongoing, it's continuous. Yeah, so no matter what, there are customer projects going into series, the development on the component continues in an evolutionary fashion. So now in case, in a customer specific solution, just very few specific changes are needed on this platform, they may be done. And this is displayed in the top map. And these changes may be on an order of magnitude 10 times smaller. If you have this, and if you really have now a branch on which the development continues, I think very similar to what Miro stated, then it can become quickly impossible to merge back both into a single base, single code base. And that actually means that your invest in the component is not carrying over any longer into the customer-specific solution. Now, thinking software-defined vehicles, this is really bad because the customer-specific solution you will want to provide updates for over 10, 15 years. Yeah? And if you cannot bring back together, this is really a whole lot of money that you're losing on that one. So that's why it's important to really create that transparency, to really bring it to the attention. Yeah, so do not create another production line, yeah, out of, let's say, a specific demand for a short period of time, because it will be too expensive in the long run. So then I come to our key takeaways. Starting from the market, we see that the attractiveness of vehicles is determined by software-based functionalities and will become even more so in the future. Yeah, and to enable this, we need an architecture that for a long period of time needs to be able to support these customized solutions. We cannot allow for specific cloned and owned solutions that we have to maintain over long periods of time. In order to get there, to really make this possible, we really have to implement these metrics. For example, metrics that we showed, maybe some others, maybe there are other good metrics as well, to really quantify and show how the flow in the software development is, and then also set up continuous improvement processes. So really, for us, it boils down to systemic level of productivity measure as well, not at the individual level of developers, not at small team scale, but really across large teams, across even maybe company borders in the co-creation. Thank you. There's